examples. So we're going to be given some functions and we are going to be required to find the domain and range so that we can choose an appropriate viewing rectangle in order to see the key points of our function. We are given that this is the original function. Now we know that there are going to be some restrictions here on x because we have a root and we see that it's 8 minus x squared. So there's a possibility for this to be negative. So that means we want 8 minus 2x squared to be a positive number. So it's either going to be equal to or greater than 0. And I'm going to solve for x to find what my restriction is. I'm going to minus 2x squared, or sorry, add, my bad, 2x squared to both sides. When we solve equations with an inequality, we can more or less treat them like an equal sign, but there is one exception. I'm going to write that on the side of our page here. When solving inequalities, okay, I'm going to call them inex. If you multiply or divide, I'm just going to use the symbols, multiply or divide by a negative number, then the arrows, so either less than or greater than, flips direction. So in my case, so again, this only applies if you are multiplying or dividing a negative number. If you're adding and subtracting, nothing changes. You can essentially pretend that this is an equal sign. So I want to get x by itself. I move x over to the other side, and then I have 8 over 2, and I don't switch directions, right, because my 2 is a positive number. X squared. So this is telling me that x squared has to be less than or equal to 4. Now, this is the part where some people get tripped up. I'm running out of room a little bit, so I'm just going to move up here. I'm going to take the square root of 4. Has to be less than or equal to x. Remember that when we have a square root of a number, it's possible for the answer to either be positive or negative. So because x has to be smaller than or equal to the square root of 4, and we are having two possibilities for our answer, we essentially put x in the middle of these two possibilities. X has to be within the limits of square root of 4, meaning within the limits of the two possibilities. And this identifies our domain. So when we set our viewing window, we can go between -2 and +2. And what about our range? Let's take a look at the function again. Square root of 8 minus 2x squared is y. What's the largest number that that y could possibly be? Okay, well, x has to be within 2 and -2. So the larger x is, 8 minus that number is going to be smaller, and the square root of that is going to be smaller. So what would maximize the y? If we didn't have to subtract anything from the 8. So how do we make this go away? We make x equal 0. Y would equal the square root of 8. That would be our maximum possible value. And our minimum possible value will be when x equals 2 or -2, right? Because then we have 8 minus 2, -2 squared, or +2 squared. It's going to give us the same answer. And this is going to give us that y equals 0. And this is going to be our minimum. So y is between √8 and 0. So that's what we're going to put in for our viewing window. We're going to go from 0 to √8. We're going to go from -2 to +2. So I'll show you how to do that. I'm going to pull up my calculator here. And ooh, I realized that I got the French version. That's all right. I believe the second button at the very top is called the window. And you can see here, X min, X max. The scale, the X scale, we're always going to leave it at 1. Y minimum, Y maximum. So my minimum for X, is -2. Because I want to see the key point, I'm just going to choose a number slightly to the left. So I'm going to go -3. You could do 2.5. That's fine too. I'm going to hit enter, go down to the maximum. To the maximum, I know that I can only go up to 2, so I'm just going to choose the number 3 and hit enter. Leave the scale as 1, so enter again. My minimum value for Y is 0, so I'm just going to go to -1. Again, I'm choosing slightly higher and lower so that I can see the key points. The maximum is √8. Okay, you can see the square root symbol just above the X squared button. 1, 2, 3, 4, 5 buttons down on the left side. You can see the square root button is a yellow script, so I need to hit the second button, the yellow at the top left. Second square root. I'm going to type, okay, instead of √8, I'm going to choose √9. Close bracket, enter. And now I have my minimum and maximum values. And then I'm going to look at what my function looks like. If I go to the top right button, the graph button, it's going to show me a window. And there's my X and Y axes with the minimum and maximum values that I have just put in the window. In order to see the actual function, I have to put it in the f of x spot, or in some calculators, it's called a y equal spot, but essentially it's the very, very top left button, and it's blue usually. So y1, so you can see there's lots of y's here. You can put as many functions as you want at the same time. So we're going to do that a little bit later, but for now, we just have one function. So it is the square root of 8 minus 2x squared. So again, second square root 8 minus 2. The button for X is the one that has a bunch of different symbols on it right next to the green button. It says X, T, theta, N. That's just the variable button. Because we have an X squared, there's actually an X squared button. I'm going to hit that. If you have a higher power, which I'll show you in the next one, it's going to be a different button. Okay, 8 minus 2x squared. Okay, I have put in my function. I have set my window. I'm going to hit graph, and it will show me that is what it looks like. So it's kind of like a semicircle. And now I can see the top of it, the bottom of it, the left and the right. And if I chose exactly my domain and range, so if I changed my window for my X min and max to be -2 and +2, and then looked at the graph, you can still see the picture. It's a little bit more stretched out because we're going from 2 to 2 rather than 3 to 3. But if there was a key point at 2 and 2, it'd be really hard to see because you don't know if there's anything happening to the left and right of negative and +2. So I always try a window that's a little bit bigger. All right, let's go to the next example. Sketch the graph of x cubed minus 150x. So here I have x cubed minus 150x. Oops, 150, not 15. Typically with polynomials, if you can get it into a factored form or vertex form, that will help you find where the key points are, and that'll help you find the domain and the range. So if I factor this, this would be x squared. No, I can only factor 1x. X squared minus 150. So I have roots at x equals 0 and positive and negative square root 150. Those are my key points in terms of the domain. Now, what about my y values? If x is 0, then y is 0. If x is, what would be a maximum? I'm not really sure how to do this part in terms of finding the vertex, but let's probably a large number. Where would our vertex be? Our vertex would be somewhere between 0 and root 50. And this looks symmetric, so it would be almost halfway through between 0 and root 50. Let's see, what's root 50 on our calculator? Let's do some math here. Okay, once you are in the graphing section, to get out of the graphing section, you need to quit. So you're going to push the yellow button again, second, and right next to it, quit. We'll bring you back to the regular screen. So let's see, square root of 150 equals what? 12 something or other. So what's halfway between 0 and 12? It's about 6.5. So let's see. What if I put 6.5 into this function? What am I going to get? 6.5 bracket 6.5 squared minus 150. Close the bracket, hit enter. Okay, so we have a vertex somewhere in the 700s. So let's choose a y value that's a little bit lower. I'm going to go to 750. So I go to my window, click on my minimum. What was my lowest number? My lowest number was going to be negative root 150. So negative square root, and instead of 150, I'm going to go slightly more. I'm going to go to 160. And then enter. Square root positive 160. Enter. Leave the scale, go to the y value. Let's go to negative 750 and positive 750. If I go to my graph, I'm going to get it very, very, very zoomed out. I'm not going to see very much because I haven't actually put my function in. So let's go to my function. I'm going to clear this. Okay, and I'm going to write x. Now, instead of writing the factored form, I'm going to put the full form in. There is no button for all the different exponents, so we're going to use the up arrow just on top of the divide sign. That means to the power of 3. Okay, so x cubed minus 150x. There we go. All right, graph. And there is my function. I can see all the x-intercepts and I can see both of the vertices. I can even tell you the direction. This is a positive cubic graph. So hopefully you can kind of see the hang of it here. We want to be able to see domain and range in a way that shows us also the key points. So here's a graph of y equals 1 over 1 minus x. We can rewrite this as 1 over negative x minus 1. In other words, I could say negative 1 over x minus 1. Well, I know that the base function for this kind of graph is 1 over x, which looks like this, with a vertical and horizontal asymptote of y equals 0, x equals 0. And the key points are 1, 1, negative 1, negative 1. This has told me that I have flipped it upside down. So that would be my first transformation, and I have moved it 1 to the right. So instead of negative 1, positive 1, I'm now at 0, positive 1. So I've moved it over. Instead of 1, negative 1, I'm at 2, negative 1. So that means my horizontal asymptotes haven't changed. My vertical asymptote has shifted 1 to the right. So in this case, because I know where my key points are, my key points have been from 1, 1 is now, let's see, that one got flipped upside down and moved over. So that is at 2, negative 1. And my key point, negative 1, got flipped up and moved over. So they are at 0, positive 1. Okay, so pretty small numbers here that we're dealing with. So I'm going to go back to our window and we're going to go from -5 to +5. And same thing with the y. We don't need to go very far. -5 and +5. I'm going to go to my y equals button. I'm going to clear that function there, and I'm going to write -1. Oh, key point here. When we have a function with a y on the outside, my default is to put the negative with the top number, or you can leave it like this and have it in the bottom, but then when you type it into your calculator, you're going to need extra brackets like this, which then makes it a little bit messy. Also, when you type a negative number, you cannot use the minus sign. You have to use the negative sign. So going back to our calculator, the minus sign is blue and it is between the multiply and adding sign, but the negative sign is to the left of the equals or the enter at the very, very bottom. Okay, so I'm going to clear this again. So I'm not writing -1, I'm writing -1. So bottom -1 divided by bracket x, whoopsie, where were we here? X minus 1, close bracket. Another thing to remember when we are dealing with calculators, they're not always super bright. So if you have a more than one term in the numerator or denominator, automatically that has to go into brackets. So I wrote this like this. Otherwise, it's going to think -1 divided by x and then -1. So it will actually graph this, which is not the same function, right? That the first one has been shifted to the right one and the second one has been shifted down one, which is not the same transformation. Okay, so here we are. We have the flipped 1/x graph shifted over to the right, which is what we were expecting. Here we have a cubic graph. Now, if we have, sorry, it's a cubed root graph. A cubic graph looks like this. We have 0, 0, 1, 1 as our key points. When we graph a cubed root, it is essentially like reflecting it in the y equals x line. And we are now going to have the same looking graph, but it will be on its side with the key points still in the same spot. Because our key points are, again, relatively close together, I don't need to change my window. Positive and -5 is fine. But let's take a look, make sure we have done this correctly. Now, cube roots, not a button on the calculator. However, let us remember that when we do a cube root, this is like saying x to the power of 1/3. So when we type it into our calculator, it's going to be y equals x to the power bracket 1 divide 3 bracket. Okay, so there is no cube root button. We are going to use the power function and use the roots as the fractions. So x to the power bracket 1 divided by 3, close the bracket, graph the function, and there it is. Just what we expect, essentially a cubic on its side. Okay. Last one, find the solution of the equation cos x equals x. When we are looking for the solution, we are looking for the intersection. When given the equation, we're going to put y1 for the left side and y2 for the right side. So what we are expecting is y1 to produce the cosine graph like this, and y2 to produce a linear thing like this. So we are looking for this spot right there. Now we know that the maximum range for cosine is positive -1, so we're not going to expand our or zoom out on our window, and y equals x will go on and on forever. So what I'm going to do here is I'm going to leave the y as positive -5. However, when I look at the range, when we have the range, we graph trigonometric functions using intervals of pi. So we need to make sure that we are in radians mode first, so that we can say the function x between positive and -2 pi. You could use numbers, but I'm going to show you this because we will use it again. So first things first, we need to go to the button that says mode. It is just to the right of the second. We are going to go down to where it says radian. So this is a third option, or degrees. Make sure that radian is highlighted. So you're going to click on radian. You see it flashing, hit enter. Now we are in radians mode. You can also change it to degrees if you are working with degrees. Then we go to the window. Okay, so now I'm going to say from -2, and the pi symbol is actually just on top of the exponent, but it's yellow, so I have to go second pi. So from -2 pi to +2 pi, and it'll automatically figure out what that number is. My y values, max and min is -1, so let's actually just zoom in a little bit. Let's go from -3 to 3. All right, so we fixed our window, we fixed our mode is radians. Now we go to the y equals, clear it. Cosine x is my first function, and y equals x is my second function, and let's graph it. There is my sine function. Here comes the y equals, and I want the intersection. So we want it to calculate the intersection. Notice that of the 4 or 5 top buttons, there is one called trace. So you could actually trace the graph along and you could kind of get close to the intersection point, but we actually want the answer. We want it to calculate it. And calculate is just above that number or that button in yellow. So second trace is going to say calculate. And option 5 is the intersection. So we want the intersection. So we go to option 5, hit enter, and we're going to use our arrows to get as close to that spot as possible. Closer, closer, closer. All right, I think that is close enough. And it's going to say, is this the first curve? Yes. Is that the second curve? So again, make sure that it's close or as possible to that point. Yes, that is the second curve. And do we want it to guess? Yes. All right, there. Our intersection is at the coordinate 0.739 for both the x and y value. So the solution is x equals 0.739. Or you can say the coordinate 0.739, 0.739. All right, that brings us to the end of the tech. You should now be able to do all of the homework for this lesson. Have a good weekend, everyone.